Today we're going to learn how to write sinusoidal functions given a graph. For number 1, the parent graph of cosine is shown below. Write a sine function that represents the graph. Sine starts at the midline, so we'll need to find a quote starting point for sine, which will be your phase shift. I chose negative pi halves. Because we know we've been given cosine, we already know the period is 2 pi. The amplitude is 1 and the vertical shift is 0. So when there's no change in period, c over b is c over 1. So just c. That makes f of theta equal to sine of theta minus negative pi halves, which simplifies to be sine of theta plus pi halves. For number 2, we've been given sine and need to write a cosine graph that represents it. Because cosine starts at its maximum, we can use the point at negative 3 pi halves for our phase shift. Or you could use pi halves as a quote starting point, and in that case your phase shift would be pi halves. Either one will give you a cosine representation of the graph shown. The period of sine is 2 pi, so the period for cosine will be 2 pi. The amplitude is 1 and the vertical shift is 0. This makes g of theta equal to cosine of theta minus negative 3 pi halves, which is cosine of theta plus 3 pi halves. Or an alternative would be h of theta equals cosine of theta minus pi halves if we used a phase shift of pi halves. For number 3, they want us to write a sine function and a cosine function that represents the graph below. I can see a period of sine starting at 0, so our phase shift is 0. Sine completes one cycle from 0 to 2 pi, so the period is 2 pi. There is a change in amplitude, which is 1/2, and there's no vertical shift. So for the sine function, we have f of theta equals 1/2 sine of theta. Simply the parent graph of sine with a new amplitude. If we are going to represent the graph as cosine, the only thing to change would be the phase shift. The period, the amplitude, and the vertical shift remain the same as we found before. I used negative 3 pi halves as the phase shift, but just like in number 2, you could use positive pi halves. G of theta is equal to 1/2 cosine of theta plus 3 pi halves. Number 4 has a period of sine starting at 0, but the period is now pi. Now that we have a change in period, b is no longer 1. Because the period formula is 2 pi over b, 2 pi over b is now equal to pi. Solve for b, and you get 2. The amplitude is 1, and there's no vertical shift. So f of theta is equal to sine of 2 theta. A period of cosine would, quote, start at pi fourths. Negative 3 pi fourths would also work. Now that your phase shift is no longer 0, the phase shift is not equal to c. The formula for phase shift is c over b, so make pi over 4 equal c over b, and because there was a change in period, we have b equals 2 instead of b equals 1, and now solve for c. So b is 2 and c is pi halves. This makes g of theta equals cosine of, remember, b theta minus c. So 2 theta minus pi halves. Try number 5 on your own and press play to check. The only thing that has changed from the parent function of sine is a phase shift of negative pi fourths. So your sine function will just be sine of theta plus pi fourths. Cosine could start at positive pi fourths, which makes your cosine function cosine of theta minus pi fourths. Now try number 6 on your own and press play to check. This time, the vertical shift is negative 2. The phase shift for a period of sine is negative pi halves. The period is still 2 pi, which makes b equal to 1, so your phase shift is c. So sine will have a phase shift and a vertical shift, making it sine of theta plus pi halves minus 2. A period of cosine would have no phase shift. So to write this as cosine, it's literally just the parent graph shifted down 2. Cosine of theta minus 2. Number 7 will have multiple transformations. For sine, my phase shift is negative pi halves. But look, the period ends at pi halves, so there has been a change in period. Period is from negative pi halves to pi halves. That distance is pi. So we'll make pi equal to the period formula 2 pi over b and solve for b. This makes b equal to 2. Because b is no longer 1, c is not automatically equal to the phase shift. The phase shift is equal to c over b, plug in 2 for b, and solve for c. So c is negative pi. There's been a change in amplitude as well. The graph goes 4 above the midline and 4 below, so the amplitude is 4, but there's no vertical shift. So the sine function will be f of theta equals 4 sine of 2 theta minus negative pi, which simplifies to be 4 sine 2 theta plus pi. For a period of cosine, we could start at negative pi fourths. This means the c value for cosine will not be the c value for sine, because our phase shift has changed. Make the phase shift of negative pi fourths equal to c over b. We already know b is still 2 because the period did not change. And solve for c. G of theta is equal to 4 cosine of 2 theta plus pi halves. Number 8 also has multiple transformations. Try finding both the sine function and cosine function for the graph below, then press play to check. For sine, I used a phase shift of negative pi over 8. I noticed that the period ended at 7 pi over 8. The distance between negative pi over 8 and 7 pi over 8 is 8 pi over 8, which is pi. So the period of this one is pi. Make that equal to 2 pi over b and solve for b. You may have noticed by now, if the period is now pi, then b is equal to 2. This affects what c is for our phase shift. So make the phase shift equal to c over b, plugging in b equals 2, and solve for c. So c is equal to negative pi over 4. The amplitude for this one is 2 because we go 2 above and below the midline, and there's no vertical shift. So the sine function will be f of theta equals 2 sine of 2 theta minus negative pi fourths, or simplified to be plus pi fourths. For cosine, our phase shift is in the opposite direction, pi over 8. Everything else stays the same, so we just need to find the new value of c. So pi over 8 is equal to c over b, the phase shift formula. B is 2, so plug in 2 for b, and solve for c. That makes c equal to pi fourths. So the cosine function would be g of theta equals 2 cosine of 2 theta minus pi fourths. And that is writing sinusoidal functions given a graph.